Guys, and welcome back to my YouTube channel. In the previous video of physical geography, we have completed geography as a discipline, the origin and evolution of the earth, the interior of earth, the sources, that is direct and indirect sources, and the earthquake, volcanism. It has also been covered in the previous video, and this continental drift theory, seafloor spreading, plate tectonics. We are done with all this. Now in this video, we will be covering the topic of landforms. So the first chapter will be minerals and the rocks. Second one will be geomorphic processes, and third one will be landforms and their evolutions. So now moving on to the first chapter. So first chapter is about minerals and rock. This chapter is missing in the new NCERT of the geography, but it is given in the previous one. Now, what are minerals? These are the naturally occurring substance, organic or inorganic. They can be organic and inorganic with certain chemical composition and a structure. So now let us look at what are the major minerals in the earth crust. So 98% of the earth crust is mainly composed of the 8 elements that are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. So this is in the sequence of their abundance. So oxygen is the most abundant element in the earth crust. Second one is silicon, third one is aluminum. Now if the question appears in the exam like which is the most abundant metal in the earth crust, then the answer will be aluminum. Now moving on to the types of minerals. Mineral can be classified into two types, that is metallic and non-metallic. Metallic and metallic can also be divided into two types, three types, that is precious, ferrous, and non-ferrous. Precious are like gold, silver, platinum, etc. And ferrous are the metals which contain iron. Non-ferrous, these are the metals that does not include iron. Examples are copper, lead, zinc, tin, aluminum, and non-metallic are like non-metallic, which are non-metals basically. Example is sulfur, phosphate, nitrates, and cement is also example of this. Now let us look at some physical characteristics of minerals. So we have a previous year question on that also. One characteristic is streak. What is this? This is the color of the ground powder of any mineral. What was the question? Is that malachite, which is a ore of copper, is green in color and gives a green streak. And fluorite is purple, and it gives the white streak. So it is a P white. Now moving on to the next characteristic, that is transparency. So a mineral can be transparent, That is, light passes through it completely and do not scatter or reflect. Now another one is translucent. That is, light is passing through the mineral but it is diffused. And opaque, that light will not pass through it. Another one is hardness. The degree of hardness is given from 1 to 10. 1 to 10. 1 being the least hard and 10 the hardest substance. So first one is talc, gypsum, calcite, fluorite, apatite, feldspar, feldspar, quartz, topaz, corundum, and diamond. Next one is specific gravity. What is this? This is the ratio between weight of the given object and weight of equal volume of water. And it can also be expressed weight of object in air divided by weight of object in air minus weight of object in water. This is specific gravity. This is about minerals. Now moving on to the rocks. What are rocks? Rock is a mixture or aggregate of one or more minerals. So study of rocks is known as petrology, and based on their formation, rocks can be of three types. That is igneous, sedimentary, and metamorphic. Metamorphic. So how does igneous rock form? It is formed by solidification of magma. Solidification of magma. In sedimentary rock, it is the result of deposition of fragments of rocks by exogenous processes. By deposition fragments of rocks. Exogenous processes. In metamorphic, it is the result of recrystallization of existing rocks. Igneous rock, it is known as primary rock. And examples of this rock is like granite, gabbro, pegmatite, etc. And the question is asked in the exam in form of like which one is extrusive or intrusive igneous rocks. So you have to remember this in series like rhyolite, andesite, granite, basalt, gabbro, peridotite, dunite and olivine. Olivine, it is also known as mother of all rocks. Why? Because differentiation of this olivine gives all these rocks. Now it is an extrusive igneous rock. Dunite, it is an intrusive rock. Peridotite is an extrusive. Gabbro is intrusive. Basalt is extrusive. Granite is intrusive. Andesite is extrusive, and rhyolite is intrusive. So these are in the alternate sequence. That is, every alternate rock is extrusive. Remember this sequence. This can be important for the exam. Now moving on to the sedimentary rocks. So these are formed by mainly the denudational agents or the erosional agents. We will learn them in upcoming chapters. So these deposits are solidified into one form, which is known as process is known as lithification. And there are number of layers of varying thickness is also formed in sedimentary rocks. Example of sedimentary rocks can be sandstone, conglomerate, limestone, shale, chalk, etc. Now moving on to the metamorphic rocks. So metamorphic basically means change of form by action of pressure, volume and temperature. Volume and temperature. Those PVT changes. Now metamorphism is the process by which an existing rock undergoes the recrystallization and reorganization to form the metamorphic rock. So it is the process. Now it can be divided into two parts, that is dynamic and thermal. So dynamic metamorphism is basically characterized by mechanical disruption and reorganization. In this, no visible chemical changes happening. So this is example of dynamic metamorphism. And in thermal metamorphism, the chemical composition changes. Now, it can also be divided into two types, that is contact metamorphism and regional metamorphism. So, in contact metamorphism, the rocks come in contact with the hot magma and recrystallizes by the high temperature changes. So this is known as contact metamorphism. And in regional metamorphism, the metamorphism take place due to the tectonic shearing. Tectonic shearing. This is the recent question asked in CDS 1 2026 about dynamic metamorphism and thermal metamorphism. Now, let us look at some properties that metamorphic rock shows. So in metamorphic rock, the minerals are arranged in layers or lines, which is known as property of foliation or also known as lineation. And there also appears sometime group of minerals arranged in alternating thick and thin layers of different minerals, which is also known as bending. Is thick and thin layers of different minerals arranged in the metamorphic rock. It is known as bending. Now, examples of metamorphic rock is Thinite, slate, marble, quartzite, etc. So these rocks does not remain in their form as it is. They are constantly changing their forms, which can be understood by rock cycle. So igneous rock, which is formed by magma, it forms sediment, which undergoes lithification and forms the sedimentary rocks. Now both these sedimentary and igneous rocks undergoes the process of metamorphism and forms the metamorphic rocks. Now this metamorphic rock can also undergo the process of lithification, or it can be formed into sediments, so it can also form the sedimentary rocks. Now in the subduction zone, these metamorphic and sedimentary rocks undergo partial melting and form in the magma, and this magma again solidifies in form of igneous rocks. So this is the rock cycle. And in the series of igneous rocks, you can also remember that the silica content, SiO2, is increasing upwards, and content of iron, it is increasing downwards. Now moving on to the next topic, which is geomorphic processes. Now geo means earth and morphic is related to structure. So in this we will study about the processes that shapes the structure of earth. Now if some process is initiated, there must be some cause behind it, and the cause behind these geomorphic processes are exogenic and endogenic forces. And now what are these forces? So as the name suggests, endogenic, that it is originated inside the earth, and exogenic, that is outside the earth's surface. So these internal forces that are endogenic forces, these are powered by radioactivity and geothermal heat of the earth, and these external forces are powered by solar energy and atmospheric climate. And now let us look at the difference between these two. So the main difference is source of energy, which is geothermal energy for radioactivity, rotational and tidal friction for endogenic forces. And for exogenic forces, it is solar energy and tectonic gradients, that is gravity. And what is the result of this endogenic force? It is building up or elevating the earth crust. And exogenic force, it helps in wearing down, that is degradation, and also deposition, that is aggradation of these weathered materials. And the processes that are initiated by this endogenic forces is diastrophism and volcanism. By exogenic forces, process initiated are denudational process, which include weathering, mass movement, erosion, deposition. So now moving on to these building forces, endogenic forces. So diastrophism includes orogenic force, erogenetic force, epirogenetic forces, earthquakes, plate tectonics. So orogen is mountain building forces, epirogen is continent building, and earthquake and plate tectonics. It also includes the volcanism, which help in the creation of landmass in form of igneous rocks. Now comes the denudational process. majorly powered by solar energy. Processes include weathering, mass movement, erosion, deposition, and end result is degradation of relief. Now moving on to the weathering. Weathering is in situ breakdown. मतलब जहां पे रॉक है उसी जगह पे उसका disintegration होना is called the weathering. Now it can be of three types. That is chemical weathering, physical weathering, and biological weathering. Chemical weathering, as the name suggests, that some chemical reaction is taking place. How does it take place? In form of oxidation, reduction, hydration, or solution carbonation. So it is the chemical weathering, and physical weathering is that, that is due to the mechanical forces like gravitational pull, thermal expansion of water, pressure, extensive heat. So these all are the causes for physical weathering. And biological weathering that are due to the uh, biological organisms, that is animals, plants, dead and decaying organisms. So this is biological weathering. Now exfoliation, it is the result of weathering, that is peeling of the surface, such as the layers of onions are peeled off. In this form, if the weathering happens, this is known as exfoliation. Now understand that climate affects the weathering. If the temperature and precipitation are high, then weathering will be more. And high heat and heavy rainfall drive intense chemical weathering. That is, temperature and rainfall is directly proportional to the rate of weathering. Second one is mass movement. So it is the movement of material under the influence of gravity. Remember one thing, in the mass movement, the material is moving under the influence of gravity, and it is not carried by the geomorphic agents. Instead, the debris can carry the geomorphic agent. So weathering aids the mass movement, but it is not necessary. Now these are the types of mass movement. That is slumping, debris or rock slide, and rock fall. Now this slumping is backward rotation movement of various layers of earth. Like this. This is one, this is two, and these are backward, pushing backwards and moving downwards. Debris slide or rock slide is sliding down of debris downwards. And fall is rock fall is falling off a hanging cliff or rock particle directly, like this. Now comes the part of erosion and deposition. So it is basically done by these geomorphic agents, that is wind, running water, glaciers, waves, and groundwater. So all these are not climatically controlled. Like this, waves and groundwater are not influenced by climate, and other three are influenced by climate. Erosion is basically transportation of what these degraded material or weathered material from one place to another, and deposition is settling down of these particles. Now comes the part of soil formation. So initially, on the there are weathered rocks. On these weathered rock, the primary life starts, like bacteria, moss, lichens. These all start growing. Thereafter comes the organic matter. That is like the dead and decaying part of these lichens and mosses. It gives rise to the humus, and there starts the primary life and vegetation. Thereafter, the mature soil layer will be formed, due to which the vegetation will start growing there. Now the factor affecting the formation of soil. These are parent material, that is the rock from which the soil is formed, topography of the area, climate, biology, and time. So these climate and biological activity like vegetation cover, humus, nitrogen fixing bacteria, and animals. So these are the active factors that are included in soil formation. And the passive factors are parent material, topography, and time. That is, they does not actively take part in the formation of earth, but it affects it. Now moving on to the next one, that is evolution of landforms. What is landform? Landform are the natural feature present on the earth's surface. So these are basically divided into three types, that is first order landform, second order landform, and third order landform. First order landforms are like continent and ocean basins, that is broad divisions. Second one is like these include some major landform features like mountains, plains, plateaus, etc. And third order landform are the landform which are carved out by exogenetic forces from these secondary or primary landforms like valleys, longitudinal valleys, and we will now let us moving on to the landform types. So they are of two types, that is erosional and depositional, depending on whether they are formed due to the erosion of some surface or by deposition of the degraded material. Now we have learned that there are five geomorphic agents which forms the different landforms. That is, first one is running water, second one is groundwater, third is glacier, fourth is waves and currents, and last one is wind. Now starting with the running water. So lifespan of a river can be divided into three stages, that is youthful, mature, and old. In the youthful stage, there is down cutting by the water. Speed of water is very high, and the features like V-shaped valleys, gorges, canyons, rapids, waterfalls are formed in this stage. And in the mature stage, the speed of the water slows down, and instead of the vertical down cutting, the lateral spread of the river starts. And here the landforms like floodplains, meanders, oxbow lakes starts to appear. And in the old stage, the speed of the river further slows down and it starts depositing the coarser sediments carrying throughout its course and forms the landforms like deltas and estuaries. Now, let us have a look at erosional features of river. First one is valleys. Valleys can be of several types, such as V-shaped valleys, as the name suggests. They are in shape of letter V. Gorges, they are valleys having steep sides. They are cut into hard rocks. Canyons, it has a step-like structure formed in the sedimentary rock, basically. Now, there are features that are associated with waterfall. That these are potholes and plunge pools. They are basically circular depression at the bottom of waterfall. Now, moving on to the depositional features. So, first one being point bars. These are sedimentary deposit on the convex side of the river. Another one is alluvial fens. As the river enters the plain area from the mountainous area, it starts to deposit the sediments and coarser sediments in form of fan-like structures like this. This is known as alluvial fens. And at the end mouth of the river, it deposits the coarse fine sediments to form the deltas. And other depositional feature are floodplains, natural levees, and point bars. I have discussed this. What are natural levees? This is river, and here they are like natural embankments. Now moving on to the groundwater. So, so the landform in the this groundwater, are basically associated with the chemical action of water, like hydration, carbonation, oxidation, and the landform formed are known as karst landforms, and they are both erosional and depositional. So, starting with the erosional feature, swallow holes. So, these are the depressions on the surface. These are shallow depressions. Then, sinkhole. It is a deeper version of swallow holes. Now comes the dolines, and doline is the swallow hole when the surface collapses. This is surface, and this is collapsed. Now comes the uvalas or valley sinks. So various dolines joins to form this uvalas. These are the uvalas. The lapis. Now comes the depositional features. These are stalactites, stalagmites, and pillars. So stalactite is the this mineral hanging from the wall of roof of the cave, and stalagmite, it is appearing from the floor of the cave. So how can you remember this? This stalagmite, leg. So leg is below, that it is rising from the floor, and pillar is when the stalactite and stalagmite joins together. This whole structure is pillar. Now the next one is glaciers. So erosional feature of glaciers. First one is cirques. These are the basins basically present at the head of the glaciers, and sometimes water is filled in them, which is also known as Tarn Lake or Cirque Lakes. Next one is horns. Horns are the pointed peaks. Next is artes, which are like this pointed ridges. Next one is hanging valleys. These are hanging valleys. Next one is fjords. These are basically glacial lakes, which are very deep glacial troughs filled with the seawater. Now moving on to the depositional features. First one being outwash plain like floodplains. Next is moraines. These are the long ridges like structure. Next is eskers. Esker are the sinuous ridges. Like the drumlins. Drumlins are the oval shaped ridges like this. Now comes the waves and ocean currents. Now the coastal areas which have hard rocks and high rocky structures, they are dominant. There the erosional processes are dominant, and the landform like cliffs, wave cut terrace, sea caves, stack stumps, these type of landforms are dominant. And in the coast which have sedimentary rocks and low sedimentary structure, they are dominated by the depositional processes. Here the structures like beaches, dunes, barrier reefs, spits, lagoons, they are found in majority. Now moving on to the last one, which is wind. These are also known as aeolian landforms. So starting with the erosional features, first one being the peneplain or peneplains. These are the low-lying structures. One being Inselberg, they are small rounded hills that are present in the desert areas. Next one is Palayas. These are basically shallow lakes present in the desert areas. Next one is deflation hollows and caves. This is a rock structure. Here wind is hitting, like this hollow structures are formed. Next one is mushroom rock, structure like this, in which this lower part is removed by the wind. Now moving on to the depositional features. Barchans, these are crescent shaped structure in which the wings, these are the wings, are facing away from the wind. Like wind is moving in this direction and they are facing clear. And now in parabolic dunes, they are opposite of them. Like in this, wings are facing the wings of the sand dune is facing the wind. And shapes, it is modified form of Barchans in which the one side of the wing is elongated. Next one is longitudinal ridges in which the wind is blowing parallel to these structures. And in transverse dunes, these are perpendicular to the moving wind. This is all about the landforms. Here is a summarized table. You can remember these names of the landforms and associated with which agent. Now, if you like the video, hit the like button and subscribe the channel and share it with your friends. If you have any suggestions, mention in the comment section.